Unit 2, opener number 10, asks us to look at a variety of statements and decide whether they're true or false. If a statement's true, let's generalize and come up with a property that's associated with that statement. When I look at part A, I see 2 plus 9 equals 9 plus 2. Let's try it out and see if this is a true statement. 2 plus 9 is 11. 9 plus 2 is also 11. So this is a true statement. 11 equals 11. What we did was we just took the 2 and the 9 and we moved them around. We changed the order. And this is called the commutative property. Commute means to move. So all I'm doing is I'm moving around my numbers. The operation that we were using was addition. So this is true based on the commutative property of addition. Number 1b also deals with the commutative property. We're just moving our numbers around. Let's check and see if the commutative property is true for multiplication. Does 3 times 5 equal 5 times 3? Well, 3 times 5 is 15. 5 times 3 is also 15. So this statement is true. So there's also a commutative property of multiplication. Next, in statement C, we're not just moving the numbers around, we're changing the way that we're grouping our terms. So on the left-hand side, we have 4 plus 1 in parentheses, plus 7. We're checking to see if that's equal to 4 plus, and then 1 plus 7 in parentheses. We have to do the parentheses first according to the order of operations. So 4 plus 1 equals 5. 5 plus 7 is 12. On the right-hand side, I have to do my 1 plus 7 first, because that's in parentheses, and that's 8. Plus 4 is also 12. So this one is true as well, and when we're changing around our grouping, that's called the associative property. So number 1c demonstrates the associative property of addition. Let's check and see in part D if the associative property also holds true for multiplication. Let's do on the left-hand side, 8 times 3 we have to do first because that's in parentheses. That's 24 times 2 equals 48. On the right-hand side, we have to do 3 times 2 first because that's in parentheses. And we get 6 times 8 is also 48. So this one's true also, and this is a demonstration of the associative property of multiplication. We changed the way that we grouped these terms. In part E, we have 7 minus 2 equals 2 minus 7. Well, it looks like we're back to the commutative property again because we just took our 7 and our 2 and we moved them around. 7 minus 2 equals 5. 2 minus 7 equals negative 5. So this time we end up with an equation that's not true. 5 does not equal negative 5. So that's false. So hopefully what you see here is that while the commutative property held true for addition and for multiplication, the commutative property does not hold true for subtraction. Now let's check out whether the commutative property holds true for division. 3 divided by 5 is 3/5. 5 divided by 3 is 5/3, and 3/5 does not equal 5/3, so this one is false also. So it looks like the commutative property is not true for subtraction, and also the commutative property is not true for division. Finally, in part G, we see another property demonstrated. On the left-hand side, we have 5 times the parentheses 10 plus 3. Let's do parentheses first. 10 plus 3 is 13. 13 times 5 is 65. So 5 times 13, which was 65. On the right-hand side, we have two sets of parentheses. 5 times 10 is 50. 5 times 3 is 15. 50 plus 15 does equal 65. So in part G, this is true. This is a demonstration of the distributive property. We're taking the 5 and distributing it to the 10, and that's where the 5 times 10 comes from, plus 5 times 3, which gives us 15. So we're distributing our 5 to the 10, and we're distributing our 5 to the 3, and then we're adding those two products together. This is called the distributive property of multiplication over addition. Be very careful when you're using the distributive property. Make sure that you truly do have multiplication over addition, and that is a true example of the distributive property. You can't just distribute every operation over every other operation, so look for this specific type of distributing before you go ahead and use the distributive property. So we saw a demonstration of 3 different true properties. We saw the commutative property, where you're just taking your terms and you're rearranging them, moving them in a different order. Commute means to move. The commutative property is true for addition and for multiplication. Then we saw some examples where we kept the order of the numbers the same, but we regrouped them in a different way, and that was called the associative property. The associative property holds true for addition and multiplication. And finally, we distributed a term to the 2 terms in parentheses, and that was called the distributive property of multiplication over addition.